Hey folks, let's have some more circle fun. Today we're going to talk about area of a circle, and that's different from circumference. Hopefully you all have some familiarity, but let's just kind of clarify what we're talking about. Circumference is when we're going around, like how far are you going around the circle? Even the word circumference, like circumvent, circumnavigate, circumscribe, those are all they have the same prefix where the circum part means to go around. So circumference just talks about how far you're going around the circle, but area, we're talking about in the circle itself. How much space is being taken up inside this circle? So circumference again is it's a length, it's a distance. Okay, but here when we're talking about area, well, we always talk about area in some sort of square measurement, whether it's inches squared, feet squared, whatever. Because we're talking about, well, how many squares of something will cover a particular surface, cover a particular area. So that's a good thing to think about whenever you're talking about area. Again, circumference, length, area. We got some squares going around. How many squares are going to fit inside of a circle? Well, that's based on this formula right here. It depends on pi and then times radius squared. I know a lot of people get confused with pi r squared versus 2 pi r. Remember 2 pi r, that's circumference. Well, the pi r squared, again, thinking of squares, that's area. So pi r squared is going to be area, and then the other one, 2 pi r, will be circumference. So let's do some quick problems. Let's do a wrestling problem, of course. Wrestlers use circles. This isn't like, WWE kind of wrestling. This is like hardcore, real deal Greco-Roman wrestling. They fight in the circular mat. And in this situation, we've got a circular mat with the diameter is 32 feet. So that's what we've got right there. But our formula for area depends on radius. So we want to use the radius. Remember, diameter is 2 times the radius. So our radius in this case is going to be 16, just half of the diameter. So that's what we'll use. And we'll plug that into our nice area formula. So it's going to be pi times 16 squared. Or in other words, 16 is 256. 256 pi. That's basically our answer. And let's throw some units on there. It's going to be 256 pi feet squared. So depending on how the answer is requested, it can be either in terms of pi, like that, or as a decimal. As a decimal, it comes out to about 804.3-ish feet squared. All right. Now, so that's not too tough to find the area of a whole circle, especially if you have diameter or radius, you're in pretty good shape. But what if we moved over to sectors? Sectors are pieces of a circle. I like to say that sectors are kind of like a piece of pie. Okay, I'll wait for the laughter to die down. I get it, pie, and then kind of a pie. Okay, so sectors. What would sector XOY be in this case? Well, XOY, the sector that corresponds with XOY is this right here. So what's the area of that sector, that shaded piece? And I just shaded in for you. Well, this is going to be very similar to our arc length problem. Remember, for arc length, we wanted to know the central angle, or in other words, the arc degree measure. In this case, it's nicely laid out for us, where it's 90 degrees. So this is a 90-degree arc. Now, hopefully, you can just look at this and say, oh, look, this is 1/4 of the total circle. So the area should be 1/4. Well, let's kind of add some math here, get some background. What it really depends on is this degree measure. So this degree measure, the 90 degrees, we want to look at that as a fraction of 360. So 90 over 360 is 1/4. And so what about the circle area? What's the total circle area? Well, the total circle area is our nice simple formula, pi, and then the diameter here is 16, so our radius equals 8. So it's pi times 8 squared, or in other words, 64 pi. So we're going to do very similar to our arc length formula. We're going to, for sector area, we're going to multiply 90 over 360 times the pi times 8 squared. Or in other words, 1/4 64 pi. And that comes out to 1/4 of 64, 16 pi inches squared, since we're dealing with inches. There we go, not so bad. And over here, we're going to again look at sector XOY, but it's a different circle. Sector XOY is this piece up here. Now, what's the degree measure? Well, they tell us the degree measure of this major arc out here. So from here to here, we've got 240 degrees. So what's the degree measure of this arc? Arc XY? 360 minus 240 is 120 degrees. Okay, so let's just do the same process for our sector area. We're going to take 120 over 360 times pi times 15 squared. In other words, that's 1/3 times 225 pi. And simplify that down some more, we got 75 pi inches squared. All right, not bad. Hopefully that's making sense to you all. And let's give a general formula down here for the area of a sector of a circle. If this is our sector, sector AOB, the formula would be the area of sector AOB is going to be, we're going to use the degree measure of this arc out here, whatever the degree measure is, measure of arc AB in this case, over 360. We want to see what fraction of the full circle is this arc, and multiply that by the area formula, pi r squared. Okay, we're going to take this a little bit further in the next video, but hopefully that makes a lot of sense to you.